Hi, welcome to lab number 1. My name is Harun Atcha, and I'm your instructor for this course. So if you've already watched the lecture, you probably already know that. These labs are organized a little differently than the lectures. For the lectures, I go out of my way to write a script, record it, and I very carefully and methodically go through the material for the day. For these labs, we do things a little bit differently. You may have noticed that I'm kind of speaking off the cuff here, and that's for a reason. So here's our schedule for today. I'm going to cover this second thing first. Why do I do things this way? Well, right now it doesn't really make much sense because I'm just talking to you with my desktop screen on the background. But really what I'm kind of hoping to do with this more freeform type of recording is to show you the kind of mistakes that naturally arise and the difficulties that you'll probably face once you start coding, and how to troubleshoot those problems and where to look for answers. For example, there's no shame in going to Google or Stack Overflow when you run into difficulties. That's kind of just the process of coding things. Those websites won't give you the answers for the problems, but in general, they'll put you on the right track and they'll help you understand where the problem lies. So not only does doing things in a more informal way kind of show you that even I, a person who has been using R for several years now, run into all sorts of problems, and it takes me some time to figure out the source of my problems too. The only difference between you and I is that you're just starting out, so you haven't quite built that same intuition about where to look and how to phrase your questions and stuff like that. But with this lab, we're starting from scratch, all the way from downloading R and Rstudio, all the way through reading in data today and kind of the general structure of how to work with R today. Second, let's talk really briefly about the lab schedule. So there are 6 labs in this course, but there's only 5 assignments. So there's no assignment for this first lab. Instead, what this lab is really meant for you to do, this first one anyway, is just to download R and go noodle around in R and kind of get familiar with it. And that's it. So let's start at the beginning, and why don't we download R? So, programming language. So one of kind of the things that is worth, here we go. So sorry, let me take a second here. So we're going to download it here from CRAN. CRAN is the Comprehensive R something network. I don't remember. And you can download it from any of these things, but since I'm in Illinois, I'm going to find a server that's relatively close. And then I'm just going to download R for Windows. And I'm going to install R for the first time. And I'm going to download the most recent version of it. Okay, so while it's downloading, a good question to ask is, what are we downloading exactly? Obviously we are downloading the R programming language, but in this class, I assume that you don't have any understanding or knowledge of programming languages in general. So basically what we've done when we download R itself is essentially we've taught our computer how to speak this language. And this is important for 2 reasons. One, it needs to know how to interpret what it is we're typing out, right? So for example, if I just opened up a notepad document and I said something like, if I wrote something like this, data.csv, this is legitimate R code, right? If I ran this through the terminal, for example, and I had R downloaded, or I'm sorry, if I didn't have R downloaded, I couldn't run this through the terminal, even though it's perfectly valid R code, because my computer wouldn't understand R yet. So really all we've done here is that we've downloaded the language, but that's a little bit different than writing R code in kind of a useful way. So, for example, all of you who are taking this course, I assume, understand English to some extent, right? You can speak it, you can hear it, you can write it out, but that's different from, for example, writing out your essay in a text editor, right? So you know English, but there's a difference in ease between how much effort it would take to write out an essay on a stone tablet, for example, and doing it in Microsoft Word. Microsoft Word has all sorts of tools that a stone tablet doesn't that make writing in English much easier. And what Word isn't like when we download Word onto our computers, we haven't taught our computers how to understand English. We've just given our computer a tool with which we can write English. Similarly, that's what Rstudio is. So unfortunately, they're named very similarly. But what we want is some tool that will make writing our code very easy. We're going to download Rstudio, which is called an integrated development environment, and is basically like what Microsoft Word is to the English language. So we've already taught our computer the R programming language. Now we need to download something akin to Microsoft Word. So we want this Rstudio desktop. It's an open source license. It is free. You're welcome. And we're going to download that, and we're going to download it for Windows. So another question kind of worth asking is, why do we even bother doing Rstudio and stuff like that? Nothing we really do in this class is so complex that we would absolutely need Rstudio. Surely I can just do all of this stuff in Excel. And, you know, you really can. To be perfectly fair, you absolutely can do everything we do in this class in Excel, but I think that's not great for kind of two reasons. First of all, that Excel is a little too flexible for your own good. And so it'll let you do all kinds of things that aren't good habits, and it doesn't really structure your thinking in a useful way. So that's first of all, right? You can kind of go in and you can manually play with or manipulate individual values of data. That's really not what we want to do. What we want is some systematic way of handling data. So that's the first reason why we don't just do all of this in Excel. Excel kind of fosters bad habits. And, you know, if you go on the job market, R is very useful. That's another good reason. The last reason is that Excel costs money. But mostly it's that Rstudio and doing things programmatically is a much more robust way of tackling our data and the problems we face with data. So when we write code, what we're really doing is we're showing a recipe of how you got from raw data to your insights. And that's really useful because especially as you move into, for example, graduate school or when you submit your final paper, what I want to see from you and what other people are going to want to see is basically your work. Show me your work. And that's what data analysis in a programming language really helps you kind of do. It helps you show your work. So you don't have to tell your boss or, peer reviewer, oh, trust me, I went in there and I changed this value manually. You can't see it, but trust me, bro, that's what I did. That we want to avoid that as academics and as conscientious people. So that's why we use R. So let's go ahead and open up Rstudio, and we'll look at the parts of Rstudio. So this is what your Rstudio is going to look like when you first open it up. Here, you'll just see kind of basic information about your version of R. This is minimally useful. And what we really want, why don't we start off with a file, new file, RScript. And then that really pulls up kind of the 4 panes that we have that are going to be useful for us. So this first pane, you can think of it as kind of that text editor portion, right? Here is where we're going to write all of our code. Here's where we're going to write all of our code in this pane right here. Now you'll note kind of off the bat that already things look a little interesting. For example, this word right here is highlighted in blue. These words are highlighted in green. And these words are light gray, as opposed to these words which are in normal dark gray or black text, right? And this is kind of the magic of what Rstudio really does. It highlights our text for us, and it shows us the parts of our code that have certain characteristics, in the same way that Word will put a little red squiggly line underneath misspelled words, or just autocorrect them, for example, right? That's your first area right here. This is like your text editor. The second area right here, well, that'll be your environment. So R is an object-oriented programming language. We're not going to go into too much depth about what that means because frankly, it just doesn't matter for this course. The way R handles data is essentially to put things into buckets. So, for example, let's say that I have a set of numbers, I have a set of 3 numbers, right? Anytime we have a set of something, we put it in C for concatenate or combine. I'm not really sure, just C, right? So let's say we have 5, 10, 15, right? And then I want to run that line of code. I want to tell R, okay, tell me what's in this set, right? And we can run that. And on my computer, that command is Control R. I think on Macs, it's Command Enter. And Control Enter might work for you too. Depends, but one of those commands will run that code for you. And you can see, every time I run it, it goes back to that line, it runs it. And it tells me what's in that set, C. That's terrific, but I don't want to have to type that out multiple times. I want to do many things with this set, not just for R to tell me what is in this set. So I need to put it in some sort of bucket and name that bucket. And then every time I say that name in R will know that I'm talking about this set, right? So I'm going to call it set, and then I'm going to assign it with this operator right here, which is an arrow and then a dashed line. Alternatively, I can just do equals. And for example, that assignment operation also works in Python, if you're familiar with Python. But I think the arrow looks pretty nifty, right? Now, when I want to call my set, all I have to do is say set, and ta-da, it shows my item. And you'll have noticed that my set shows up here in my environment pane. Right? This is how I keep track of all of the objects that are currently existing. In R, we can manipulate objects in many different ways. So, being the statistical programming language, we can do all sorts of real nifty statistical operations on it. For example, we can do set plus 5, and that'll add 5 to each element of my set. Very cool, right? 5, 10, 15, 10, 15, 20. We can also set times 5, and sure enough, 5, 10, 15 turns into 25, 50, and 75. Likewise with, likewise with subtraction and division. Okie doke, awesome, right? So these are pretty simple arithmetic operations. Arithmetic operations? Either way, that's what it is, right? So R can do all of these very cool things. Another thing you'll have noticed is that when I put the pound symbol, then everything I write here has this kind of light green color. And these are what's called comments. So anything that comes over this pound symbol is not going to be run as code. It's basically me telling R, don't pay attention to this. Don't run this as code. This is just kind of verbatim what I tell you, just spit it back to me. So you'll notice, for example, that when I run code on the line where there is a comment, it'll just do the first actual bit of code after the comment instead. Terrific. So Great. It does. R's magic is in doing these arithmetic operations across many sets and data sets and other stuff like that, right? Like you could manually go through and add 5 to every single data set, data frame that you have, but that's very tedious and we want R to take care of these large things. So great. Well, but the thing is, right, so now we've covered what this area does, and we've covered more or less what this area does, and this down here is our console. So if we tell R to do nothing else but to do things like print my set, it's going to push it down to that console right there. And if I just call an object like I did here, it's going to also print it down to the console. So most of what we do actually doesn't print out to the console. For example, if I reset, right, if I override my set, now I have a new set, you'll notice that it told me what command got run, but then it didn't print out set again, right? So most things that we do actually don't show up in the console. We usually have to tell R, print this out to the console. So now we've covered 3 of our panes here. We've kind of oriented ourselves a little bit. This last pane is usually our graphical output. So this will become clear in a little bit what we mean by that. But why don't we go back and let's do another set, and we can say set 1, 2, 3. And we want to name it maybe like set A. Set A and set B. Let's do that. So we have 2 sets, one of 5, 15, and 10, 5, 10, 15, one of 1, 2, and 3. Right? So let's make a comment. So good code is well commented code, and let's just say, instantiate some sets. We're going to bring some sets into existence. And then why don't we go ahead and get rid of that? And so the next thing we want to do is basic arithmetic. Here's another fun thing. So you'll notice that if I just ran this from the top as it is right now, these wouldn't work because I don't have an item called set in my code right now. So for example, I'll press this little broom button, it'll delete all of my objects. And let's say I run these, it'll go boop. Uh-oh, object set not found. Well, what I can do is that this sets both objects. So that's kind of a goofy thing R has that you can do. Okay, so basic visualization. That's what we want. So base R, set A, set B. Base R has some pretty ugly looking graphics. And so basically all I just asked it to do was to say, we have 2 sets, and I want you to put set A on the x-axis, and I want you to put set B on the y-axis, and I want you to gaze into your crystal ball for me, R, and I want you to infer what type of graph we're trying to make. So we'll get into a little bit more depth about why that's a bad idea and why we focus so much on visualization in this class in the next module. But for now, what we really just want to look at is to notice that our chart popped up here in the bottom right corner. So as we get further and further on into the class, you'll end up doing things like making maps, making bar charts, a whole lot of bar charts, making histograms, other things like that. And for the most part, they'll all show up down here in the viewer panel. We'll call this the viewer panel. Okay, so, we've done the basics of orienting you towards R. So, that's terrific, but a lot of the times the projects that I'm working on need to be persistent. That is, it's not enough for me to kind of manually type in all of the data. That's a huge pain in the rear end every single time that I want to do any analysis, especially if my data set is really big. That's not a good thing for me to sit in here and manually type. Like, oh, this is my first set, this is my second set and variable. What I want is a place where I can save my projects and then systematically load my data. So why don't I go ahead and do a folder on my desktop called test area. And then I'll go ahead and save my file as test code. We'll get rid of this for now, right? So I've saved my test code here. And then why don't we go ahead and make a data set, a tidy data set that we learned about in this last lecture, so that we can pull it into R and do some manipulation with it, right? So why don't we recreate some version of our favorite color data set. Let's do favorite color and count. You'll note that in all of my file names and variable names, I try really hard not to use spaces because R has a super tough time dealing with spaces, and you got to do all kinds of goofy things to make it understand spaces correctly, right? So whenever possible, don't use spaces in your column names and don't use spaces in your file names. So let's just do stuff like green, blue, red, gray, pink, purple, yellow, and that's it. That's all the colors I can think of right now. And then why don't we go through and just pick random numbers. Okay, so we're going to go ahead and we're going to save this as a text CSV. And we're going to call this data.csv. This is in the same folder that our script is in, our R script is in. So we have two columns, two variables. Our first variable is favorite color. Our second variable is like the number of students who like that. And this is just random data. Great. So let's go back to our folder, and you'll notice here's our code, here's our data, right? If we want to read our data into R, we just have to run this read.csv function, right? So if you're ever curious about what a function does, all you have to do is type in question mark and then write out the name of the function. And in this viewer plot, it'll tell you what it does. So description: reads a file in table format and creates a data frame from it with cases corresponding to lines and variables to fields in the file. So you'll note with cases corresponding to lines and variables to fields in the file, that's basically just the description of a tidy data set. So let's go ahead and let's get rid of this so I don't hear that. Let's go ahead and let's try to read in this file. Error in the file. Cannot open file data.csv. No such file or directory. Okay, so we have some problem here. And the problem is that wherever R is looking for this data file, it's not finding any file called data.csv. Now, we know it's in this folder, so either I misspelled data.csv, and one thing to note is you always have to put the file extension whenever you read a CSV file, or really any file, right? If it was a different type of delimitation, then we'd have to put in that type of delimitation. But for this class, we really only work with .csv files. So back to the point, wherever we're having our look for the file, it's not finding it. And here's an important kind of clue down here. So this is basically telling us where R is currently looking. That's called the working directory. And our working directory, you'll notice, is not test area. So we need to tell R to look in test area because that's where our data is. So we can do this in a number of ways. We can click this button right here, and we can try and we can find it, wherever our test file is, but that's kind of a huge pain in the butt. We could do it a different way, which is to manually set the working directory with set WD, and then we can copy the path in here, right? So now we're telling it, look in this area for our data file. And since these backslashes are escaped characters in R, we just change all of them to forward slashes or whatever type of slashes there are. Great, right? So we run that code, and now we're telling R, hey, when you read CSV, look here. Alternatively, I could have just done this, right? I could have told it exactly where the file was, but that's a huge pain in the butt, and I don't want to do that. So we've set our working directory. Now we can read in our data, and look at that. Wow, it was such a miracle. We've loaded our data set into R. Right. So we've done this, we've done this. Why don't we take a look at our data set? So you'll notice that I assigned my data to an object. Data, it's called data in here. So if I just say data and say, hey R, what do you see in data? It'll print out the whole thing. I don't always want to do that because most of our data sets are too large for me to stare at like 1,000 rows of something and 500 columns of something, and R will really start to chug if I ask it to do that. So maybe what I want is just the first 5 rows. First 5 rows. And I can do that by using the head function. So if I type head and then data, it'll show me rows 1 through 5. And you'll see that it doesn't show me yellow, for example, because that's row 6. If instead I want to see the last 5 rows, I can type in tail instead, right? And it won't show me green because that's the first row that I have there. Terrific. Alrighty, so now that we've loaded in our data set, there are some steps we should take to kind of understand how R saves those variables. You can tell, for example, when we printed out these variables that, like, categorically speaking, these two things are different, right? The count variable here is exclusively numbers, and so we want to be able to do arithmetic on them, and for R to understand them as numbers. And the favorite color column is a character column. That is, we don't want there to be some sort of misunderstanding that R has that these are really just numbers in disguise. We just want them, we want R to treat these values as characters. And so we can look at that. We can access specific columns in a few different ways. Why don't we look at, first of all, the way that we can do that in base R. That is, if we don't use any other tools, any other kind of add-ins, how can I look at a specific column in a data set? So we have our data set here in data. The first and probably easiest way to access a column is just with the $sign. And you'll see when we click the $sign, this kind of little pop-up will show up, and it'll show us all of the columns in our data set. For now, why don't we just pick favorite color, and it'll tell us all of the values in order of what our favorite colors are, right? You'll see green, blue, red, gray, pink, and here green, blue, red, gray, pink, purple, yellow, purple, yellow. Great, right? So this is one way of accessing variables. That's one way of doing it. Another way of doing it is through matrix notation. So we can say, okay, my data frame is basically a table, right? This is the way, this right here, This whole thing is called a data frame, right? So I kind of use those words interchangeably: data sets, data frames. They mean different things, but for our purposes, it's close enough to use either one of those. Okay, so my data set really just kind of like a giant matrix, and each of these values has a coordinate, for example, right? This is in the first column and the first row. So the way matrix notation works is accessing via matrix notation, row, column. Maybe we can call that row number and column number. And let's see what I mean here, right? So let's say I want to just see the first row of this data set. So I just want to see row 1, and I'm going to put a comma. And since I want to see all of the columns, I'm not going to put anything here. So R knows that I'm just looking for everything. And when I run that, sure enough, it brings up the first row. Likewise, I can do something similar if I want to do just the first column. I can say, okay, show me all of the rows, but only for column number 1, which is favorite color. Great. And you'll notice that that does the same thing that this did. Sometimes doing it this way is more useful. Sometimes doing it this way is more useful. More often than not, referring to columns by name is a little bit more robust of a way of doing it, and we'll see why that's the case a little bit later on. But in general, that's how we access variables. We can also say, okay, show me what's on row 5 and column 1. Pink, right? We got a value. So basically, when we kind of want to check to see if our columns are misbehaving, this is probably a good place to start. Put that $sign notation, pick out the column you think is being troublesome, and just take a look at it. As long as you don't have enormous values or a huge number of them, this isn't a terrible way to see if your data set passes the sniff test. So data types. Why don't we get into data types a little bit? As we noted, these things, count and favorite color, are kind of qualitatively different, and though you may not know it yet, R understands them as different. So there are a couple of different classes of variables. So why don't we say class, data, and count, and what we get is integer. That's good, right? We want R to think, what class is count? We want R to think that this is a count variable because, remember all these arithmetic operations we did up there? We can say something like count minus 2. And look at that. It'll give us our answer back. We're manipulating our data set in a possibly useful way, right? Later on in week 6 and 7, we will get to centering and standardizing our variables. That is, how do we put our variables on a scale that is useful? And basically what we're doing is just that. We're saying take the average of all of these numbers and take it out of the raw count. And yeah, that's what we get. Now, this doesn't look very useful right now, but as we get further in the class, it will become more useful. But note that we're already kind of putting together functions that we've learned about and their implementation in R. So we can do these things by column. Why don't we take a look at our favorite color example, and it reads it as a character variable. Now that's very useful. And if we try and do the same thing, times 2 maybe, it'll say non-numeric argument to binary operator. Basically, what R is telling us, that's not a very informative error message, but what it's telling us is, I don't know how to multiply green by 2. I'm sorry, Professor Acha. I just can't do that, right? And it'll tell you the same thing. It's not just being stubborn for me. And that's also a good thing, right, in a sense, because we don't want to accidentally do operations that don't make any sense. So that's very useful. So these are kind of the 2 data categories that we're going to work a lot with, or at least mostly with. One other, what class is count? What class is favorite color? One other class of variable that you might run into quite often is the factor. What is a factor? A factor is an ordered character variable. As we go through levels of measurement, you might notice that this definition is very close to ordinal measurements. So it's still a character, right? We still can't do arithmetic on it, but we do want, for example, when we plot, those characters to be in a particular order that maybe isn't necessarily alphabetical. So, for example, green, blue, red, gray, pink, purple, yellow. Maybe we don't want these to show up in a bar chart where it always puts yellow last. Maybe yellow is a very popular color, right? And it looks like it is. And so we want it to be that, like, let's see, purple is our most popular color. So when we're making a bar chart, we're going to want purple to be at the front, at the very first value. And then we're going to want either yellow or blue. And then we're going to want green. And then we're going to want, I don't know, gray and then red, right? None of those are in alphabetical order, and are, if we don't tell it to put it in a specific order, we'll just put them in alphabetical order, right? And so we can change data from one type to another, though we often want to be careful when we do that. So we can change it in the, for example, factor with a factor, or as factor. This also works. As factor. Right? And you'll notice that this time when we run that code, it's not just telling us what are the values in this variable, it's also telling us, hey, the levels in this value, the levels in this variable look like this. And you'll notice that they're kind of no different from alphabetical right now. But if I wanted to change these around, and I wanted to put yellow first and then pink second and then red third, I could tell factor to do it that way, right? I could tell as factor in the levels argument, right? So I could say levels, and I would have to tell it how I wanted to order these things. I could say, let's just say we want to do it backwards. So yellow, red, purple, pink, gray, green, blue. Unused argument. Right? So it would seem that as factor is different than factor. So I've run into an issue here. And my problem is that I used the wrong function. So why don't I go through and try that? And sure enough, it works properly. And note that this order of things now looks like the order of things that I told it to. Remember, anytime we put things together, we have to put them inside of these C brackets. And since I'm talking about specific values and not objects, I have to put them inside of quotation marks as well, right? This is a little bit less important than kind of understanding what an integer is and what a character is. But that'll be useful once we start to do more visualizations, and you'll see in the code that I provide you for the slides in the modules and for some of the further labs that we do, I make a little bit more use of these arguments to make our charts look nice. So let's see what we have left to do. Okay, we've done data types. Now we need to talk about, very quickly, hopefully, libraries, dplyr, and pipes. Okay, so as you can see, R is actually quite useful on its own. If I just use the tools that R is giving me, I can do quite a lot of things. I can make my own kind of data. I can play around with data. I can do arithmetic on that data. And as we learn more complicated things like the variance, the covariance, the mean, and standard deviation, we'll quickly realize that R can do all of those things for us. I can also do very basic visualizations, and R will put them very nicely up here. These aren't all that illuminating right now, but we'll do some more interesting things later on. R can also, look up data and load in data for itself. And then I can look at the data. It can tell me, what does one variable or two variables look like. I can access that data in a number of different ways, and I can look at the class of the variable, and I can change the class of the variable. But all of this kind of like column notation is a little bit cumbersome, and you'll start to recognize that as you go further into your data analysis. This isn't a super great way of doing things. For example, let's say, I have my count variable, and let's just say that I forgot to count one from each of these observations. So the way that I would have to change that would be to say data count plus 1. So this part does the actual addition, right? And I'm assigning the output of this back to the column where it came from. So if I didn't do this, if I just did this, right? And then I went and I looked at data count, it would still have the original values. It wouldn't have these values that I've manipulated. Instead, I need to tell it to put these changes that I've made into data count. Now, when I look at data count, it'll give me those updated values. So terrific, right? I can manipulate a column. But this is a very cumbersome way of doing things, and just by looking at it, it's not clear why I would do things this way. So R has its limitations, at least base R does, and this is where libraries and packages come into play. We're going to use a particularly expansive library called dplyr and the tidyverse that are going to make our data analysis much more easy and much more readable, so that when I'm grading your homework, and more importantly, when you're going back and you're looking at old code, you can understand what it is you were doing, right? So think of a library as kind of an add-on, right? Okay, well, the people who programmed R in the first place did a terrific job, but they didn't think of everything. However, they gave us the tools we need to build our own tools. And so a lot of people go out there and they build their own tools. So to use those tools, we need to do two things. First, we need to install them by typing in install packages, and let's download the dplyr package. And since this is the first time that I'm downloading these things, since I have a fresh install of R, it's going to take me a little bit of time to do that. Not that much time, but now it's done, right? Now I've installed it. Now I need to call the package. I need to tell, why don't I put this on two separate lines? Install packages dplyr, and I'll comment that out because I've already done it, and call a package. And now I want to tell R, hey, I'm going to be calling some functions from this package. So I would like you to load it, please, right? And it's done just that. You won't see any output. It's basically just saying, got it, boss. Now dplyr is waiting in the wings. If you want to use anything from dplyr, I'm going to use it from now on. So why is dplyr useful, and why do we bother using it so much? Well, sometimes we don't want to just do one function at a time. We want to make many different changes, and then we want to plot those changes, right? Or for example, we want to do many things to our data set, and what I don't want to do is something like this, right? Data is count equals data count plus 1, and then also don't forget to do this divided by 5, and then okay, data count one of these guys right there, right? Whoops. This is a very kind of cumbersome way of doing things, and I don't like it, right? There's kind of 3 lines. There's a lot of repeated stuff here. Why do I have to say data $count like 5 different times while I'm here? It's unpleasant. It's an unpleasant way of doing things. And it's not very programmatic, right? What we kind of want to avoid doing is having these random floating numbers around here that are kind of arbitrary. We could accidentally change them. They're kind of prone to error, so that's not great. What the dplyr package does is that it organizes the way we do our data analysis. So in all of the functions that come with dplyr and that are collectively known as the tidyverse, all of our functions, data is the first argument. So you can just think of dplyr as a set of tools that will help you manipulate your data sets. So let's take a look again at our data set. Okay, we have our data set right here. Now you won't understand all of this code, but that's okay, because right now what I just kind of want to show you is a proof of concept. So let's say what I want to do is I want to take this, I want to take the average of my count, right? I want to start with this data set. I want to take the average of my count. I want to normalize these, meaning I want to take the average of this variable out of every observation, and then I want to plot it on a bar chart. So, like for example, gray and red, which have below average, I would assume numbers, would show up as kind of negative, and purple, which has an above average number of count, and yellow would show up as positive lines. So one operator, pipes are great. One operator we need to know is the pipe. And the pipe basically says, and then do X. So anytime I do my data manipulation with dplyr, I'm going to start with my data. Again, this is what my data looks like. And then I say, okay, what do I want to do with that? I want to change one of my variables. We'll call that mutate. And here's the terrific part of using dplyr. Instead of doing something like this, data count equals data count minus mean data count. This is a very verbose way of doing things, right? We don't have to do any of that. Since I've already passed in my data set, I can just say, I can just take out all of these data counts, right? And dplyr will understand that I'm talking about the count variable. We can just refer to variables by name here. And what I'm saying is, okay, for the column titled count, I want you to take whatever's in count right now and subtract out the average. And when we run that, that's what we get. Terrific, right? Well, now I want a packages that will do nice plots for me. Plots are very important. Visualization is terrific because bar charts and scatter plots are very cool. All the cool kids are doing them nowadays, and you should do them too. Peer pressure. Lots of bar charts, great. So now we have our data set. And remember, since I didn't assign this to anything, every time I run it, it just prints it to the console, right? If I looked at data right now, it looks different. These two look different because I haven't assigned data, right? If I did that, then when I reran data, these two would look the same. But since I haven't done that, and I don't want to do that yet, I'll leave it as is. Great. So that's the first thing I've done. Let's next say that I just want the last 5, or I guess 6 observations. So I'm going to put the tail function in, right? So here's what I'm saying. And again, I've added the pipe here. So I'm telling dplyr, and then do this, right? So I'm saying start with data, okay, and then change this column so that we subtract the mean out of every value, okay, and then just take the last 6 values for me, and let's see what we get. Yeah, great. That's exactly what I'm looking for. I don't want that many values. I just want to plot these last few for whatever reason. And then what I want to do is I want to make a plot. So I'm going to start with my basic plot. And remember, in the tidyverse, your first argument of a function, that is the first input is always data, so I don't have to write this. It's okay. It knows that I'm talking about the data. So I'm going to say, okay, make a plot, and it's okay if you don't understand this part yet. We'll do it in the next module. I would like you to add a column where X is my favorite color and Y equals my count. So let's go ahead and run that and see what we get. Yeah, that looks great, right? And here you can kind of see the benefits and downsides of having a type of variable that is a character versus a type of variable that is a factor. So in fact, now that I've made my bar chart, I kind of noticed that I want to put things in a specific order. What would be real freaking nifty was if I could put purple first, and then I could put one of these two next, blue or yellow, and then, I don't know, pink, and then gray, and then red. I think it would look really nice if I could start with the biggest observation and go to the smallest observation. It's a little bit more visually arresting, I think. So, you know, writing things with dplyr makes that really easy. So I can say, okay, you know, what I really want is actually for my favorite color variable to be a factor. Right now it's not a factor. Whoops. Favorite color. Let's see if that changes anything. It doesn't, but that's really just because it took my things and it just kept them in the same alphabetical order that I told it to. Well, so just like this time, what I did here, I need to tell it what levels I want to, what order I want those levels to be in. So why don't we do that? Why don't we say, okay, the next argument is levels, and I want you to put it in this order. First, I want you to say, okay, purple comes first, and then let's say blue comes next, and then yellow comes after that, pink, gray, and then red. And let's see what we get. Yeah, okay. Now I think this looks pretty good. I think this looks pretty good, right? It's a nonsense example because we're not really working with any actual data. But note that every time I make a change here, I only have to rerun one line of code. I don't have to go back and say, okay, first run data, then assign it to some item, then run this, then assign it to some other item, right? And for example, if I wanted these to change, the color of these bars to change based on their magnitude, all I would say, or all I would have to add is to say, okay, the color aesthetic varies by count. Whoops, sorry, fill. Right, and look at that. I think that looks pretty good. That looks pretty good. And all we had to do was add that one argument. We didn't have to go back and change this whole chain, right? At its core, this is a recipe. This is our recipe for how to take our data and turn it into some kind of insight. So ultimately, when you do your homework, it'll look nice and neat, kind of like this, right? I don't expect you to have perfect indentation or, you know, oh my gosh, how could you not get this, use this specific argument or function like that? Really what you kind of have to do is play with it long enough to discover some of the functions that you think are going to be useful to you and that produce nice insights, right? So let's see if we've covered everything we need to. So dplyr, pipes, right? And so essentially what we've done in this first lab is to cover the very, very basics of R. Now, I haven't gone super in-depth into every single step you need to take to, for example, understand data types, how to troubleshoot every single problem that you might run into. I have linked to a number of R resources on your modules page, so if you run into difficulty, either go check those out first, which I would highly encourage you to. There are a ton of good R resources out there, or you can come to my digital office hours that I'll hold probably once a week. And I think the TA will also hold some office hours so that you can get help with this, right? Your first steps into a programming language, even if it's R, usually not very simple. This stuff comes simple in these labs because I've been doing this for a long time, right? Don't ever be ashamed of having difficulty with any of this stuff. It's not an intuitive way to think about things until you've been doing it for a long time. But in this module, what I've hopefully done is introduce you to some of the basic tools that you're going to need and expose you to some of the capabilities that R has to make your analysis way easier. As we go through some of the other labs, we're going to do way more complex things than just counting up the average or normalizing things. We're going to be working with data sets that are really big, and that's kind of on purpose. And that's because I don't want you to, if you get frustrated with R, just to go into Excel and manually calculate all of these things if you know how to use Excel, or do it by hand, right? If you're using R, you should get some use out of it. And you'll notice that once you get good at it, that it takes no time at all to go from data set to visualization. Your speed from thought to analysis to output becomes really quick. And hopefully that's what you kind of build over the next few weeks. So as I noted, let's wrap up here. Let's talk about what we covered. We talked about our schedule. Again, there's no homework for this week, but for the next 5 weeks or modules, there will be homework assigned and associated with each lab. We're doing things this way in this kind of unstructured format so that you have a better sense of mistakes, what they look like when they happen, how to troubleshoot them when they do happen, stuff like that. We then downloaded R in Rstudio. We went over the parts of Rstudio. We talked about the text editing area, the environment, the console, and the viewer panel. Then we talked about working directories and loading data. That is, where does R look when it's looking for your file that you have asked it to load, and how do you load data into R? And since we'll only be working with CSV files in this class, then I showed you how to do that. Then we talked about data types. We talked about the difference between integers and characters, for example. We talked about the usefulness of libraries overall, and then we went over dplyr and pipes and why they're so useful. So there's no homework associated with this lab, but I hope you'll spend some time noodling around in R, trying to load your own data sets, so that next week when we do lab 2, you are already ahead of the curve and you are at least a little bit comfortable in loading data and manipulating it using simple arithmetic operations. All right, if you have completed this and if you have any questions, please don't hesitate to look out or reach out to me, and I'm looking forward to seeing you in the next module.